Okay, so moving along in our packet, we're going to be talking about some of the trig values of the common angles of unit circle, which is extremely valuable to us to know, especially when you move on to upper level maths, calculus, and so on. Um, the biggest ones that we're going to come across are going to be based upon 30 degrees, 45 degrees, and 60 degrees. Those all come from special right triangles. Um, let's take a look at the columns where it says the radians. First of all, you need to be able to convert between degrees and radians on these common angles very quickly. We did talk about how to get some of those angles on one of the previous pages in this packet. If you remember that 30 degrees is basically 1/6 of the top of the circle, because it is 30 degrees goes into 180 degrees 6 times, and 180 degrees is the top half of the circle. Because 30 degrees is 1/6 of the top half, 180 degrees, this is very important. I always tell people you kind of just need to know this one. 180 degrees is the same thing as pi in radians. So if I take 1/6 of that, which is 30 degrees, then I'm going to take 1/6 of pi, which is pi/6. Make that look like a 6. 45 degrees is 1/4 of the top half of the circle. Therefore, 45 degrees is the same thing as pi/4. And then 60 degrees is 1/3 of the top half of the circle. Therefore, 60 degrees is pi/3. Again, you just need to know those conversions very, very quickly. However, it takes it for you to know that in your head. So now let's talk about the sine and the cosine of those particular angles. If you remember way back to geometry, you have a triangle and you have some kind of an angle, which we'll call theta. Make that actually look like a theta. The sine of an angle is the relationship or the division of the two, it's the ratio, I should probably say, of two of the specific sides of the triangle. And we label those sides as, given the angle, the one that's across from it is the opposite side. So I'm just going to put an O. The one that is next to it, but not the hypotenuse, is called the adjacent. Adjacent literally meaning next to. And then the longest side of a right triangle, which is across from your right angle, is the hypotenuse. So if you kind of remember your acronym SOHCAHTOA, sine of an angle is just the ratio of the opposite over the hypotenuse. Opposite over hypotenuse. And then the cosine of an angle is the relationship of the adjacent over the hypotenuse. And if we were doing tangent, which is not on this specific chart, tangent would be the opposite over the adjacent. All right, so let's go ahead and look at why all this stuff works out. So if we were to sketch our 30-degree or pi/6 angle, if you have colors, it might be a good idea to use colors for this, just so you can, it'll get a little messy if you don't. If you don't, it's fine. So I have a distance from 0, 0 out to that point on the graph. And that point on the graph is created by an angle, of 30 degrees or pi/6. But I can create a right triangle based upon that if I simply drop a perpendicular to the x-axis and then create a right triangle here. And the reason I want to do that is because I'm ultimately trying to figure out what is that ordered pair right there. What is this point on that graph? Again, this all comes from special right triangles. Ultimately, this is a 30, 60, 90 right triangle. And the length of the red piece is 1, because this is a unit circle where the radius between the center of the circle and any point on the side of the circle, on the outside of the circle, I should say, is 1. Well, again, if you remember your special right triangle stuff, which I'm not going to go into in this video specifically, that would make this shorter side, or the opposite side of the 30 degrees, 1/2, because it is 1/2 of the hypotenuse. And then that makes this bottom piece the square root of 3 over 2, because you take the short side and you multiply it by the square root of 3. So that makes figuring out these ordered pairs relatively easy. Well, the sine, actually, let me fill in the ordered pairs first. The x is going to be square root of 3 over 2, and the y is going to be 1/2, just looking at our triangle. The sine of pi over 6, or 30 degrees, is the opposite side, which is 1/2, over the hypotenuse, which is 1. Well, when you divide something by 1, it's what the numerator is. So 1/2 over 1 is 1/2. So the sine of pi 6 is 1/2. So now let's take a look at what the sine of 45 degrees would be. I'm sorry, the cosine, excuse me, of pi 6. Let's just go straight across. Cosine of pi 6 would be the adjacent over the hypotenuse, and the adjacent side here is square root of 3 over 2, once again divided by 1, so it's just square root of 3 over 2. All right, I hope that makes sense. Now, if we take a look at the 60-degree angle, I'm going to skip the pi force and come back to it. The 60-degree angle is made up to there, because basically I'm doubling that 30-degree angle between here and here, which is going to give me a 60-degree angle, which again is pi thirds. The length of that green ray right there, or the green segment, is also 1. And then once again, I can drop, I'm trying to find a different color. I guess we'll go with orange here. I can drop a perpendicular, and then I can create the bottom. And in this case, the angle here is, again, the big angle is 60 degrees, which makes this angle up here 30 degrees. So it's, again, it's a 30, 60, 90 right triangle. Again, I have the hypotenuse, which is 1. This time, the short side is not the side that's on the right, it's on the bottom. So the short side now, in this case, is going to be the 1/2, where the long side is going to be that square root of 3 over 2. So the point over here literally just changes from what it was at 30 degrees. The x and y literally just change spots there. And now we can say that the sine of pi thirds is going to be the opposite, which in this case is square root of 3 over 2 over 1. So square root of 3 over 2. And then the cosine of pi thirds is going to be 1/2, because that'll be the adjacent, which is the 1/2 at the bottom, divided by the green 1. So we've got square root of 3 over 2. Oops, wrong spot. That should be under the 60 degrees. Square root of 3 over 2 and 1/2. One thing that I can tell you, when I was doing this in school, I chose one of these 4 specific angles to memorize, and then I just kind of knew the other ones, because if one of them is 1/2, if either sine or cosine is 1/2, the other one is a square root of 3 over 2. Whether it's positive or negative will depend upon the quadrants, and then vice versa. So I chose to memorize the sine of 30 degrees, or pi 6, was 1/2, and then I could figure everything else out from there, just because I knew that they had to be opposites. Whatever works best for you, but you're going to need to know them, and you're going to need to know them hopefully without having to sketch out an entire circle or arcs every time. So come up with a way in your own head to figure those out. Pi fourths should really be the easiest one on there, because the sine and the cosine happen to be the same. Let's show why that is. So I'm going to go with purple. Again, this is going to get really messy here. I apologize. But if I go straight out to there, and then I drop and then move aside over here. Well, now this becomes a 45, 45, 90 right triangle. And because it's a 45, 45, 90, this side and this side happen to both be the same. And by, again, figuring out that this angle, excuse me, that side right there, the hypotenuse is 1, you can get that these are both going to be 1 divided by the square root of 2. If you rationalize that, which means you get the square root out of the denominator, you'll see it also written as square root of 2 over 2. Again, I'm not going into that process. Hopefully we already know how to do that. Both of those two things are the same. So the sine and the cosine of pi fourths, or 45 degrees, is square root of 2 over 2. Easiest one to remember. So all the pi fourths sine and cosines are going to be some form of square root of 2 over 2. All right, that takes us through the first quadrant of the main angles that are not quadrantal angles, meaning not 0, not pi halves, and not the ones on the xy axis. All right, we will come back and we will fill in the rest of the circle as far as how we know the sine, cosine values based upon the rest in a second video.